Hey, how's it going? I'm Max,
I'm Josie.
and we're back for another Nuclear Insiders
Episode.
Today we're going to be talking about enrichment and the history of enrichment and the process of, mining uranium to turning it into a processed piece of fuel we can use for inside of reactors.
So to start, let's go from the very beginning. Uranium was discovered in 1789 by a German scientist. His name was Martin Klobroth. I think I'm definitely saying that last name wrong. He named it after Uranus, the planet, and that's kind of where it all began. In 1911 is where we start getting into the whole beginning idea of enrichment. It's when Frederick Soddy discovered the isotope. If you don't know what an isotope is, it's the variation of an element, which means it has the same number of protons, so it's still the same atomic symbol, but it has a different number of neutrons, so it has different properties and purposes. And then we get into uranium specifically and their enrichment.
Yeah. So uranium, naturally occurring uranium, is composed of three major isotopes. We have uranium-238, we have uranium-235, and uranium-234. And uranium-235 is the only nuclide existing in nature that is fissile with thermal neutrons and is capable to use in reactors. One thing that's also interesting is the process of how uranium is mined, actually. So, because it's not as simple as, finding this rock in the dirt and then you can start enriching it. Uranium's mined and then it goes under a milling process to extract the uranium. And that is done by a combination of a bunch of different chemicals. And then after that, you have a concentrated form of uranium, which is also known as yellow cake. We'll put a picture in right there. It's yellow cake, but you don't want to eat it. You don't want to eat that cake. Not that one. So after they have the concentrated uranium yellow cake, it goes to another milling process where it's further processed to obtain the desired form of uranium that is suitable for nuclear fuel production. And that undergoes conversion to uranium dioxide or uranium hexafluoride, which uranium hexafluoride is the one that can be enriched to use in a bunch of different nuclear reactors and processes.
But this is where it gets complicated because although U-235 is the only one capable for fuel, only 0.0 or 0.7% of all uranium found is 235.
Mm-hmm.
The majority of uranium is U-238, and then U-234 is such a small, it's just honestly not even relevant. But so, like we said, we have different isotopes and we have enrichment. We need to get the U-238 to be U-235 so we can use it for our reactors.
Yeah.
And we do that in enrichment.
And there's different types of uranium, enrichment. There's natural uranium, and then we have low enriched uranium, which is, that's like reactor grade, what goes into power reactors. And then we have highly enriched uranium, which is more used for weapon grade stuff. And then there's high assay, low enriched uranium.
Which is like the new modern reactors you see. Now let's talk about the history. So the U.S. specifically used gaseous diffusion as our first form of enrichment. This was commonly used at the K-25 sites, which most people don't know what that is. It's located in Oak Ridge, Tennessee, and it's where we enriched the uranium for the first atomic bomb. As well as several others.
I didn't know that. That's interesting.
And these sites were decommissioned for weaponry use, but we're still using them to progress in our nuclear fuel cycles.
And there's a lot of different types of enrichment methods out there. There's the gaseous diffusion, there's thermal diffusion, there's a whole array of centrifuges. There's gas centrifuge, there's a zip centrifuge. And more recently, there's laser enrichment as well that's happening, which is really exciting. And yeah, there's all sorts of types of enrichment out there. It's all fascinating stuff.
So we started with gas centrifuge, and then we started with gaseous diffusion, and then the US moved on to gas centrifuge, which is currently the only enrichment process used in the United States. There's, I believe, only 1 or 2 plants currently in use, but there's others with plants in them, as well as laser separation has become a huge boom in the nuclear sector. It's progressing forward quite fast, and it's definitely something that we'll be adding on to.
That concludes our video for this week. We hope you enjoyed. We just want to go over enrichment and isotopes and uranium and shed some knowledge on the world and to YouTube and everyone. So
if you're interested in learning more, you can subscribe here, follow us on TikTok, Instagram, anything that pleases you.
we'll see you guys next week.